Hello everyone, so we are starting a new unit. This is Unit 9, Heat. So this unit is even shorter than the last unit. So today you will be doing the first subject, exo versus endo, and heat versus temperature. Tomorrow you'll do specific heat. Monday you'll do enthalpy. Now your test will be on Tuesday, but the lab is on Wednesday. So your digital notebook's actually not due till Wednesday, so you can do the lab. The reason why I'm doing that is so you're not having to take a test the day before Thanksgiving break. It gives you a little extra day to make sure you get everything done. So this first section is exothermic versus endothermic and heat versus temperature. So your topic is heat versus temp, and your goal is I can describe the difference between heat and temperature and explain how heat can be transferred. Of course, you could pause the video wherever you need to make sure you write everything down that's on the screen. Alright, so the first vocabulary definition you need to know is temperature. You need to know that temperature depends on particle movement. So it's not about how hot or how cold it is dependent on how the particles are moving. So all matter is made up of atoms that are moving, even solid objects, they are moving. They're not moving as much as liquids or gas, but they're still moving. The motion from the atoms gives off energy. Which brings us to the kinetic theory, which we talked about the kinetic molecular theory in the last unit. And this is the same thing. We know solids are vibrating atoms, liquids are flowing atoms, and gases move freely. And then plasma moves incredibly fast and freely. So to add the temperature, you need to know that it's the measure of the average kinetic energy of all the particles in the object. So the faster they move or the more they move, the hotter it will get. So that temperature is directly related to the movement, not how hot or cold it is. So how does a thermometer work? So a thermometer can measure temperature because the substance of the liquid inside of the thermometer expands, increases, or contracts, decreases by a certain amount due to a change in temperature. And they just mark that thermometer so you know what temperature it is if it's at a certain height. You really see that in the thermometers that look like the sticks that we typically use in the lab. Of course, there's also digital thermometers who can process the information it gets through like a little computer to get that. All right, your next vocabulary word is thermal expansion. So all gases, liquids, and most solids expand when their temperature increases. So this is why bridges are built with segments that look like this picture up here, and that is to allow for expansion specifically in the summer. If that's not there, the bridge could collapse, which is no good. So that brings us to heat. We know temperature relies on the movement of particles, whereas heat is the flow of energy from an object at a higher temperature or higher movement to an object at lower temperature or less movement. And then specifically, thermal energy is the total random kinetic energy of particles in an object. And again, I know I'm not stopping to talk long enough for you to type because I know you can pause the video and keep it paused as long as you need to write the notes down. Alright, so the way heat transfers in three ways: conduction, convection, radiation. So take a second, go to your next slide in your digital notebook. You notice you have, let me zoom in for you, a chart. In these first boxes, it says types of heat transfer. So in the top box, you need to put conduction. In the second box, you need to put convection. And in the third or the last box right there, you need to put radiation. So I am going to go over the definitions and talk about some examples. You can just write the definition in this chart instead of in your notes section, and then you can write your example in that as we go. So don't forget to fill out this chart as I go over convection, conduction, and radiation. So the first thing I'm going to talk about is conduction. So the definition, what needs to go in the definition box next to conduction, is the process that moves energy from one object to another when they are touching physically. This is where you get conductors and insulators. Conductors transfers that energy easily, insulators do not. So an example of this is when you hold a nice warm mug of coffee or hot chocolate on a very cold day, it warms your hands up. And that's because your hands are touching that coffee mug or whatever cup you're using, and conduction is warming your hands up. That's also how hot hands works. Okay, convection. The definition for it is the process that transfers energy by the movement of large numbers of particles in the same direction within a liquid or gas. So, an example of this is boiling water. So, the water is not touching the heat source itself, it's in a pot. Another example is a heater in a room. So when a heater turns on, it will eventually warm the entire room by convection. It's just that movement of the air that changes the temperature. Now, convection does happen in nature. That is how clouds are formed. Cooler, denser air sinks and the warmer air rises. So the movement of the sinking and rising of the warm and cold air is how we get clouds and air currents. Then the third type is radiation. Now we had a whole unit on radiation earlier on in the year, so we're not going to talk about it too much since we've already studied it. But radiation is the energy that travels by electromagnetic waves like visible light, microwaves, infrared light. So this is like laying outside and the sun is shining. You get the warmth from the sun. Well, that's an example of radiation. It's also like how if you were to touch a light bulb as soon as it is like started or as if it's on, it is hot. That is also a form of radiation. Okay, so here's just a little review chart. It's not like the chart that you were writing in, but it's just kind of some key tips and some definitions and examples. You can pause and read through this. But that is it for this section. So you need to make sure that you have the three types of heat transfer, the definition, and one example each. The example could be one that I talked about, or it could be one that you thought of on your own.